All right, hello, everyone. Students, this is part 3 of Foldable number 2, and this is going to be our last problem for this section. This is based on the continuous compound interest, which let me actually border this here so it doesn't kind of bug what we're actually working on. All right, so suppose that you won a contest at the start of 5th grade, and that deposited 30, that'd be great, but $3,000 into an account that pays 5% annual interest, compounded continuously. How much will you have in the account when you enter high school? 4 years later. Should be a comma here. 4 years later. All right, so in order to do that, we're going to use a different formula. We're going to use our continuous compounded interest formula, which I'll actually write in right here. And basically, it's the same, very similar of the a to the t, but it's going to be a little different. A to the t is equal to our principal times e to the rate and the time. So the annual rate, so it's going to be e to the annual rate plus the time. Or not plus the time, multiplied by the time. Okay? So it's very similar to the other one. We're still going to have our principal amount, or the initial amount is what you're working on. And then we're going to have our rate and the time. It's just the only difference is this, and we have our e. So we're going to go ahead and set this up. Oop, should have moved that. There we go. So we have, start in blue. So once again, we have our A here is equal to, I'll just do it here and substitute, P times E to the RT. So our A is still going to be a mystery because that's what we're solving for. It's going to be equal to our principal is 3,000 times our E, because the E is not going to change, but our rate is, so our rate is 5%. But when we change this from a percent to a decimal, we take the 5 and move over 2 decimal places, and we get 0.05. So our 0.05, and it's going to be multiplied by our time period, which this one is annually, it's 4 years. So we multiply that by 4. All right. Then we just have to multiply this through here. So we get, this is equal to 3,000 times e to the, and then 0.05 times 4, I believe, is 0.2, but I'll work it out real quick. Let me just do the math real quick. So 0.05 times 4 is equal to 0.2, which was correct. And I did that on Deadmos, which you can do in your graphing calculator as well, but Mr. Pan forgot his graphing calculator like a genius. So we're going to work that out. And now all we have to do is equate this here, and it'll give us our function that we're going to do. And once again, we're just going to use Desmos here since we don't have our graphing calculator. If not, you can use your graphing calculator. It would give you the same answer. So we just get 3,000. We're going to multiply it by, E. And then we're going to raise E to the 0.2 power. And it's going to give us our, click the next line, but it's still that one. Our answer, which is 3,000. So this is going to be, so our A is going to be equal to $3,664.20. I know we can technically round, but if you have 20 cents plus change, like in a little bit, you don't have 21 cents. So I'm going to leave it like that, even though probably should round. But you can also just kind of just show it. It's approximately $3,664 as well. This one here. And as always, since this is a word problem, we're going to answer the question in a word problem. So the amount in the account, let's put to the nearest, because we did round. To the nearest, oh my god, I'm forgetting how to spell, dollar amount, comma, is, we'll just put $3, 3664, period. Okay, so, and that's what we will do.